experience across multiple projects and many companies, whether it is startup or large company, the average number of test cases per day per person is between 8 and 10 test cases per person per day. Again, this is not a standard. You cannot come to the interview and say, you know what, Jana told us, he said 8 test cases per day, so this is how we count it. No, this is my experience, and this is how people estimate. And for simplicity, let's assume it is 10 test cases per day. And again, we are talking about manual black box testing, which means we treat the software as a black box. We don't look at the code, we just open the UI, the user interface, and we run our test cases. This does not include test case design, so we assume test cases are already written. Some maintenance maybe, but it does account for the bug logging, right? So if you find some errors, we'll be logging bugs, and when the bugs get fixed, we'll be verifying those bugs. Now we have 1,000 test cases, 5 people, 10 test cases per person per day. So 5 people during one day, how many test cases can execute? 50, right? So for the team of 5 people, we have 50 test cases per day. Okay? That means, how many days do we need to execute 1,000 test cases? 20 days, right? So then, for the 1,000 test cases, we need 20 days. If we get, and we are talking about business days, right? Which means 4 weeks. So this is 4 business weeks. Does it mean if you start on January 1st, we'll be done by January 29th?
No, that's just approximate.
No, the right answer is no, because first of all, this is very approximate. Number 2, on top of these 20 days, this is execution rate, when we just take the test cases, we run them, and maybe we log 1 or 2 bugs a day. But when you get the first version of the software, believe me, you'll be logging bugs left and right. So there is no way you can do 10 test cases per day, right? So bug processing takes time. Plus, there will be cases where you'll get stuck because software may not be even installable, and you'll spend some time trying to install the application. And there may be some other unexpected, things and hiccups on the way. So what experienced managers do, they add few days on top of it. So-called fudge factor. It is a general project management term. It's not something relevant to software industry only. So this fudge factor is about 20 to 25% of the time. Let's say 25 for simplicity. So 25% of 20 days is how many days?
5.
5, right? So it is 5 days, which means if we add these 5 days on top of this 20, what we'll get in the end is 25 days is the approximate length of our test cycle. One test cycle where we are planning to execute 1,000 test cases with 5 people. And this gives us 5 weeks, right? So, 25 days, 5 weeks. If you start on January 1st, will we be done by February 8th or 7th or whatever, 6th? Will the software be ready to release? No. Why not?
Because bugs need to be
Right.
retested.
Right, so when we run our first cycle, first of all, it is very unlikely we'll be able to execute all our test cases. Because when the first version of the software comes to you, to QA department, it is full of bugs, usually. And by the way, how many of you know what build is? Build in terms of software development? No? Okay. Okay, so let me spend a few minutes on this. So basically, what is a software program on a high level? I'm not going into details on a high level. When you have to install a program, you got the CD, you need to install a HP printing center, right? What do you have on that CD? Driver. What is a driver?
It connects the software that connects the.
It is software that
device
connects to,
with the
but physically what it is?
It's a
It's
program.
files. It is set of files, right? Any software program is set of files. It can be written in different language. It can be written in Java, C++, C#, Visual Basic. There may be some elements of JavaScript, anything. But basically it is set of files. Different languages, different formats, but set of files. So when the program is first delivered to you, let's say for simplicity, you have 3 files in your program. Usually it's tens and hundreds and thousands of files, but for simplicity, let's assume we only have 3 files. And these files, when developers write them, they write them in human-readable language, right? Java is a human-readable language. C++ is a human-readable. C is, any language is human-readable. But does computer understand those languages? No, computer is a machine. It understands which language? Binary, zeros and ones, right? We need to transform this human-readable language into zeros and ones. And this is done through the process called compilation. Compilation is done by special softwares which are called compilers. So they take this code written by programmers and compile it. So basically they check for the syntax and they check for all the references across the files and some other syntactic errors and dependencies between the files. And at the end, what you have the binary, you have a set of files in binary format. The output of the compilation is the zeros and ones, whatever those are the instructions that will be sent to the machine, and machine will run the code, right? This is how it is done. So, but when these 3 files are being compiled, as I said, compilers will check for some of the errors. It will check for dependencies, and compilers will check for the syntactic errors, not all of them, but most, clear, evident ones. However, compilers do not check for logical errors. And for some other, there may be some miscommunication between the modules that compilers will never catch. And that's why we need QA, because nothing can replace human eye. Nothing. Even test automation cannot replace human eye. So basically, when you get this version of the program compiled, and you get it, this set of files, as you get as a program, is called, in the software world, is called build. So this particular version of the files that you get compiled together is called build. So let's say this is a file called A, and this is the first version of the file, this is file B, and this is the first version of the file, and this is file C, and this is first version of the file. So this is your build. This is what you receive from developers when you start your testing process. And there are bugs in these files, right? The bugs that compilers could not catch. So let's say, I can use some color. Those are bugs, they will be red. Okay, this is the bug. And this is a bug, and this is a bug, and this. So these red circles are bugs. Okay, so these bugs, you can have hundreds and thousands of bugs in your software. When you don't have any test cases, when you use exploratory testing or ad hoc testing, as many people call it, what you do, you open the software, right? You install it, and you start testing, left and right, and chances are you will catch some of those, insects. You will find some of them. But the purpose of us having, when I say us, QA department, so the purpose of QA department having, the large and systematically developed set of test cases is that we don't shoot in dark. So we don't go here and then here and then here. This is not the way we want to go. So instead, what we want to develop a net. So we want to have test cases for each and every code path. So we can go through these files in a systematic manner and catch, as many bugs as we can. Can we find each and every software error? No, still no. It's just not feasible because the number of permutations, the number of ways how users can use your software is, very large. And theoretically, you can keep testing until you find all the bugs. But probability is it will be like 2 years from now. And by the time you're ready, you will have the most perfect software in the world, but nobody will like it because you'll miss your market opportunity by that time. So what usually people do, they try to catch the most critical bugs. And when I say critical, means those are the bugs, the errors that impact user experience, that lead to system crash or data loss. Those are very critical issues. Of course, there may be critical usability issues, installation issues, so all the most critical bugs need to be found, captured, and fixed. And to find those bugs, we can find those bugs by using systematic, testing, where we develop a set of test cases and we start our test case execution. So let's say you receive this build number 1, and you start your test case execution. Remember, we have 1,000 cases, team of 5 people, and each person is doing its own area. Let's say this is one person, this is another. So 5 people, each doing their own tests. And of course, some of those bugs will be found. So once you find a bug, and by the way, how do you know that you found a bug? How do you know you found an error?
There's a behavior mismatch.
From the behavior mismatch. Behavior mismatch between what and what?
Expected and actual.
Expected and actual. Okay, so you have, when you develop your test cases, you provide the expected behavior of the system in your test case. When you execute your test case, you look at the behavior of the system and you're trying to match what you see on the screen with what is written in the test case, right?
Yes.
Let's say if it matches, you can happily go home at the end of the day. If it doesn't match, what do you do? Reproduce. First of all, you need to repro. You need to go back a few steps, if possible, of course. There are cases where it's not easily doable, but in most of the cases, like 99% of the cases, you can go back to the previous state of the system and reproduce. Why? It is very important to reproduce your error.
The programmer can do it.
No. What programmer?
So the software developer can do it.
So the software, okay, this is a good, reasoning, but not the most important reasoning. Okay, can you just talk one at a time, sir?
We need to understand what is a system. It's not our error, it's an error of developer.
Okay, so it may be also some other issues, right? Maybe networking, maybe anything else. But the main point is that when we reproduce, why do we need to reproduce? We need to reproduce to make sure that the steps that we actually did are indeed the steps written in the test case, right? Because we are also humans, we easily get distracted. You may look at the window and then you forgot to press, keys ABC, and then you went somewhere, and then the error popped up. So you need to try to recall, because if you roll back your actions and then go through the steps and you do not see the error, that means that either you messed up, first time, you didn't follow the exact steps, you did something else. Then you try to recall what you did to cause the error to pop up. You need to play around, and eventually, believe me, you will figure it out. Or there are some random errors that just pop up because of networking issues. Network was down or something, it was slow. Those errors are hard to reproduce, but once you get, if you test your software long enough, you will be able to recognize those errors. Still make a note. You cannot fail a test case if you could not reproduce the error. You may still log it and say, could not reproduce on the first attempt. Or you can make a note to yourself, and when you run more test cases, see if you can catch the same error again. Eventually, what you can do at the end of the day, if you saw that error or similar errors a few times, but you never were able to narrow down the steps, it was popping at different random intervals, what I highly recommend, you still log it in the bug tracking database, and you attach the system logs. Do you know what logs are? Logs are actually files that are created by the program. When the program runs, it writes each and every action which the program is doing into a log file. So when programmers, they look at the logs and they can figure out what's going on. So even if you as a user, as an end user, as a tester, you don't have the exact steps to repro the issue, just mention it. Don't say always when you click ABC you get it. Say, I got this error while doing this and this and this. Maybe same error, or it may have different format, but the text, maybe the message, error message may be the same. Then say, okay, this is what the problem is, and these are the logs that I'm attaching. Please see if there is anything. Yeah.
Let me go on record for a second. Guys, we have, well, in the industry, we have different ideas of what's test case, as Yana mentioned. So here in the school, we are sticking to the concept that test case is something very small, very, very small. So when you hear something like 10 test cases per person per day, you think probably we didn't know yet what test case is about. Some people use test case like high-level test case. We have another instructor here. She works for medical devices company, and I had a discussion with her, and she says test case could be huge. I'm saying, wait a second, test case is per requirement. You have requirement, you have test case. You cannot have 10 test cases per one requirement. I mean, he said, no, Michael, he says, requirement could be real big. And then you have one test case for a big requirement, and it might take the whole day to do the test case. So the requirements, and that's not really requirements, you can make smaller requirements out of that, so you can have thousands of test cases. So when Yana started to tell you, what if something happened on the network or this and that, it is because it's big. And since it takes lots of time, there might be some interferences which impact the long-term stuff. If your test case is button enabled, button disabled,
yeah, it is very simple. There are cases that are very simple. The cases we will write today with you are very simplistic test cases. And for those, I mean, you will not have any interference. But if you go through actual user flow, let's take a shopping cart, right? You always, all of you shop at Amazon, right, or somewhere. Let's say your test flow, there are some test cases that you cannot run in isolation. Let's say if you need to test the checkout process, you need first to log in, to make some selections, to put some item in your test cart, and only then you can test the checkout, right? So if along this flow you get some errors, during this flow, the entire process can take you 15 minutes, half an hour, depends on the server performance, on how many items you have in your list, and then you may have these random errors, yeah. But again, first you need to repro, right, to try to understand how to repro the issue. And what do you do then? If you repro the issue, you reproduced it successfully. You know that if you do steps A, B, C, you do not get the expected result. What do you do next? Always?
Write a bug report.
Always? The answer is to write a bug report. My question is, do you always write a bug report right away?
Yes.
Mm-hmm. And what if it comes back to you saying there is a change in the requirement or a change in the specification?
So try to look for the documentation.
Right. So before you log a bug, there are some errors that are clearly bugs. For example, if you run some flows and user unfriendly error pop-ups to you saying, Java internal error cannot find some files, blah, blah, blah. Clearly software error. You don't need to go anywhere, look for documentation and check with developers whether you should get it or not. You should never get user unfriendly messages. But if your test case is saying, click this button, make sure there is a confirmational message that the file download happened. You click the button, you don't get the message. Instead, on the taskbar somewhere in the bottom, you have the record saying, okay, download task started and finished or whatever. If you log this bug, most likely it will come back to you saying there is a change in the design. So my message is to you, when you run your tests, always use your brain. And by the way, your brain is the the most important thing that you need in testing. So your gray matter is what matters the most. So try to analyze and be proactive, and do not necessarily follow the test case step by step. Just think when you run it, think about what you're doing, and keep in mind that the software requirements or design may change. Let's say they started with the confirmational messages everywhere. Whatever you click, whatever you do, you get a confirmational message. To dismiss the message, what you need to do? You need to click, you need to take mouse in your hand, right? Click somewhere on that OK button or whatever the button is, accept, and continue with the flow. If you have too many messages, it is very irritating for the user. And it's possible that, let's say, marketing people, they conducted the usability study and beta phase, or just some customer forums, and customers didn't like it. And they said, okay, we don't want it, it's too problematic to click everywhere. And then they decided, okay, let's change the design. And instead of giving the messages, let's just give some, on a taskbar, let's give some messaging there instead of pop-ups. And of course, I'm pretty sure you'll get this feeling. As you start working with software, you see, okay, there are no message here, there is no message there, there is no message here. Instead, you see, the taskbar messages everywhere. What you do, first you check with your peers, whether it is, there was a, change in the design. Then you check the documentation and see if the documentation is updated or not. If it is not updated, what you do, you go to developers and ask, double check with them, and ask them to update the documentation. So your test cases are not in discrepancy with the design specs. So this is on a high level how you do it. But let's say you double check and yes, the specs haven't changed, and whatever you see is the error in the software, then you log a bug. Make sense? Okay, good. So let's say you log the bugs, and when you log a bug, where does it go?
Bug tracking.
Okay, it goes into the bug tracking database, and in the bug tracking database, to whom does the bug go?
The manager.
Not necessarily. It may go to the manager, but most likely to speed up the process, to whom? To developers, right? So you may not know the exact developer who worked on this module, in which case usually the bug tracking systems are made in a way that when you pick the functional area and particular feature against which you are logging the bug, it will go to the default feature owner from development side. It may be a manager who serves the semaphore, and manager can redistribute the bugs in the team, development team, or it may go directly to the developer. It all depends on how the database was set. Once the developer gets the bug, what he's supposed to do, or she's supposed to do?
Try to reproduce it.
Try to repro, and then?
Try to fix it.
Not try, fix it. The developer is supposed to fix the bug. When you log a bug, of course, you provide the priority and severity of the bug, right? And that will tell the developer how bad the bug is. But usually when the developer is experienced, he or she will know. If there is data loss or system crashes, it is a P0, a high priority bug with a catastrophic severity. Those bugs will be fixed, should be fixed first. And then the other, not so important bugs. But anyway, some bugs will, by the way, live in the program forever. And the program will die with those bugs in it. And that may be still okay, we'll talk about this later. So, but anyway, all the critical bugs are supposed to be fixed. So, let's say you tested this version of the program, which was build number 1, which means file A version 1, file B version 1, and file C version 1. You file the bugs, developers fix the bugs. How do they fix the bugs? They open each and every file, they make fixes, right? They find those faulty lines, they provide the fix, and what they do then? They recompile the program again, right? Because they make the fixes in a human-readable file format, in those C, Java, C++ files. Once they provided the fix, they recompile everything into binary format again. So let's say when we get the next build, so the next build will be made by file A version 2. Let's say file B was not touched because developer didn't have time, or the bug was not critical enough, or it was not found, for example. So let's say this will still be version 1. And file C let's say, is version 4, because we had multiple developers working on those bugs, and each of them were checking the file out and checking it back in, so the file version was increased every time. So once all this is recompiled again, so we have build number 2, right? So in this build number 2, we have these bugs. Let's say this bug is fixed, this bug is fixed, this was not fixed. They thought they fixed it and they didn't. This was never found, let's say. Okay, this is fixed and this is fixed. Is it the true picture of the next build? Not really. Because developers are humans, as we said, right? They make mistakes. They make mistakes when they develop the first version of the software. And they also make mistakes when they provide fixes. So there is such term as bug injection rate. Bug injection rate.
Yeah, why don't you mention the version control tools since we talked
Version control,
yeah.
yeah, okay, I
Just
will. Yes.
for the coverage?
Yes, sure. So bug injection rate is approximately a number of bugs introduced by developers while fixing 10 bugs. So for example, when they fix 10 bugs, how many new bugs they introduce? So the average rate in the Silicon Valley software industry is between 25 to 30%, which means that for each 10 bugs that they fixed, they introduced 2.5 to 3 new bugs, approximately. I'm not saying they have to to introduce those bugs, and but this is the reality. So this is how it looks. The statistics look, and so which means if we had 1, 2, 3, 4, 5, 6 bugs. Let's say for those 6 bugs, they introduced 2 more. Right? How can we find these bugs? We can find these bugs when we start our cycle all over again. So it all actually depends on when we get this new build, because if, let's say, we already done with half of the testing and we can continue, what we can do, we can refresh our builds and continue our execution, finish all the test cases, and then, because by the time we finish, we may have build number 3, number 4, and once we're done with executing everything we can start a new cycle. And on the second cycle, we will capture the bugs that we already missed, right, with the builds. So there are different methodologies. Some companies restart the test cycle with each and every new build, but it may not be feasible. It depends on how frequently you get the builds. Because in the biotech company I was mentioning, where I worked, we were getting the builds every 4 weeks. So between the 2 builds, we were able to execute everything, all the test cases we had that were executable. In my present company, we have 3 builds a day. So there is no way, and the test cycle takes a week. So there is no way we can execute, all the test cases on each and every build. So we just install some builds, run the test for 2-3 days, maybe a week. Next week we switch the builds, we move, the builds up, and we go forward.